Okay, so this one is a little tricky because we haven't necessarily worked with pentagonal pyramids, only square pyramids, and we work with cones. But it turns out this is actually just going to be the same thing. We're going to do the area of the base times the height and multiply it by 1/3. We have the height as being 6. All right, so now let's go down to the base. The base is a pentagon. And we know that each side is a length of 16 centimeters. So we need to remember how to find the area of the base. Now, remember that this pentagon is actually split up into 5 triangles, right? Each of those triangles has a base of 16. So to find the area of the base, we're going to have to find the area of one of those triangles and multiply it by 5, right? So what we normally do is we have to find the height of the triangle, and then we multiply that by half of the base, which is 8. Oh, sorry, no. We just multiply by the whole base, which is 16, right? And then we're going to multiply that by 5. So then the general formula for the perimeter of a regular polygon is just perimeter times apothem and then divided by 2. And if we were to go through the whole process again of finding the area of this pentagonal base, we would just get to this formula again, perimeter times apothem divided by 2. So we know the perimeter, we need to know the apothem, and the apothem is this height. So what we have to do is we have to do right triangle trig using one of these right triangles. Okay, so pull this over. We have a base of 8. We don't know the height. Okay, but we do know this angle because this is a pentagon and it's split up into 1, 2, 3, 4, 5 triangles, right? So we do 360 divided by 5, which tells us that this whole angle is 72, which means that if we pull over that red triangle, half of it is going to have to be 32. Okay, and I apologize for the messiness, but this angle is 32. So then we can do some right triangle trig here. We have the opposite, we have the adjacent. So what we can do is we say tangent then, TOA, tangent of 32 equals opposite 8 over adjacent h. Opposite over adjacent. And then what we want to do is we want to solve for h, which if we do all the algebra out, we're going to end up switching h and tangent 32. We multiply by h on both sides and then divide by tangent 32. So we get h equals 8 divided by tangent of 32. Okay, so let's type this into a calculator. Make sure your calculator is in degrees. 8 divided by tangent of 32 gives us an apothem of about 12.8. Okay, so then to find the area of the base, we have to do perimeter times apothem divided by 2. The perimeter is just 16 times 5, which is 80. So now we're ready to do this. 80 times 12.8 divided by 2. All right, not so bad. So we do 80 times 12.8, divide that by 2. We get about 512. Okay, so then that's the area of the base. The height is 6, so then we just are going to finish this up by saying V equals 512 times height divided by 3. Okay, so 1/3 area of the base times height. So 512 times 6 is 3,072. Divide that by 3, we get 1,024. And then let's check our units. It's centimeters, so we have 1,024 centimeters cubed. Sweet. So your extension then is, instead of making this a hexagon, let's make it all the same conditions, except this is no longer a hexagon. Your extension is we're going to make this it's no longer a pentagon. We're now going to make it into a hexagon. Same side lengths, same height, But now instead of having 5 sides on the base, you have 6 sides. Go ahead and find the volume there. Okay?